Amazon.com. Oops. I do need a mic. If I'm being recorded, I need a mic. Anyway, I was just saying how happy I am to be here and happy that you're here, and this is going to be awesome, and we're going to talk about DevOps in the cloud. As you just heard, my name is Seth Eliot. I'm a developer advocate. I've actually been with Amazon as of yesterday for 13 years. Now, I started in 2005, so if you could do math, I left and came back. So a lot of that time was spent on the .com side of the house, the non-AWS side of the house. I'm with AWS now. And with the .com side, I mean, even 2005 was before AWS existed. One of my roles a few years ago was as an embedded solution architect, working with teams across Amazon on their AWS adoption. So I got to fly over the world to Amazon's offices all over the world and work with engineers on how they're building on AWS. So that is some of what I'm going to share with you today, is these stories, these experiences of working with these teams. Okay, there's a wall. You're at a DevOps conference, right? Do you know what a wall means? You don't even have to shout it, just show of hands. Anybody know what a wall means at a DevOps conference? No? Okay, should I put a silo instead of a wall? Would that have made more sense? Yeah, okay, yeah, okay. So that's the wall between developers and operations. That's the wall that DevOps seeks to break down. Now, I share that with you because there's lots of different models, the way to do that. Some people call them topologies. Some people call them organizations. How do you set up your team? Do you have a dedicated DevOps team? Do you have development and operations separate and they have a certain process for working with each other? Well, there is a model that was used at Amazon and has been used since the very beginning. Amazon was founded in 1995. And that model is you build it, you run it. There is no separate operations team. Now, everything I say has exceptions. Amazon's a huge company and there's asterisks and exceptions after everything. So if you happen to work at Amazon and know of an operations team, yeah, I get you. But in general, the default model is no operations, development team builds it and runs it. So what's that a picture of? That's a picture of a pager, right? That is not my pager, but that is a real Amazon pager. I got that from a colleague. He's probably had it for like 10 years. The pagers have been mostly replaced with the pager app on the phones now, but when I started in 2005, that was the state of the art for how you reach someone when they're on the ski slopes, because every team, since they own their system in production, has to nominate an on-call person that takes like a 1 week or 2 week shift, and if there's any major issues or bugs, they need to be able to respond and fix them. So you end up with a case where you have a single team that owns everything from designing and implementing and coding, but also to deployment and operation of their services. And this is just one model amongst any. I'm not trying to pitch it as the be-all. I'm not trying to pitch it as the best model. I'm just saying this is Amazon's model, and I'm going to show you how it works at Amazon. And that team, that single team that owns all those things, is the two-pizza team. Have you ever heard the term two-pizza team when talking about Amazon? Yeah, I heard I heard a very unenthusiastic yes. All right, so I won't belabor it. I will say it's a team that can be fed by two pizzas. Why say it that way instead of giving a number? This is part of the autonomy of the team. The team gets to choose its size as long as it's reasonable. A team of 2 fed with 2 pizzas is kind of silly. You're eating a pizza each. A team of 20 fed with 2 pizzas is kind of silly. So somewhere, not 2 and 20, but more like 7 to 10 or 11. It gives the team that autonomy to choose. And they do have ownership over their services that they may own. They may own a single service. They may own multiple services. They have control over that, and in terms of picking the technologies they're going to use, and to some degree, the feature set they're going to be implementing. That autonomy piece is really about understanding the product, whatever that service is doing, and then planning the roadmap for that service, how it fits into that product. And in order to do that, you might be thinking, oh, how do a bunch of developers know what to build for some front-end system? Well, it's not just developers, it's multidisciplinary. In addition to technical folks like developers and QA and UX designers, well, there's also UX designers, but there's also product folks. The product folks, the product owners, product manager is actually the role name, product owner is the agile role. The product managers understand the customer, they understand the environment, and they work with the team to develop what features they're going to be developing. And this is all within the context. It's not they're free to just do whatever they want, right? There's rules around security, there's rules around privacy, and there's organizational goals. So within that framework, they're free to do what they want, but they also, it rolls up to bigger and bigger orgs. And just to remind you that that picture I just showed you in the previous slide. They build it, they run it. Again, that's going to be the theme we keep coming back to. But when I say that to you, hopefully some of you are skeptical, especially unenthusiastic yes guy. Hopefully you're skeptical when I say they build it, they run it. You're thinking, that's ridiculous. My developers should be working on code and adding value, and I don't need them to figure out how to deploy. I don't need them to be figuring out how to use what continuous deployment pipeline to use, figuring out what monitoring and observability system to use. There's a lot of what we call undifferentiated heavy lifting, or sometimes called the muck, right? This is stuff you have to do to get a product out the door, but doesn't really add any end user value. It's necessary, but the end user doesn't really see the value other than maybe improved quality, of course, which is important. So we don't want to be reinventing the wheel. And this is the key. This is the key at Amazon. Tools and frameworks. So tools and frameworks could be third-party tools, and we could talk a little bit about that. At Amazon, there's a long history of developing their own tools and frameworks internally. So you can see it's two PTs, two pizza team. Two pizza teams own services and products that are internal tools and frameworks that are used by other two pizza teams throughout Amazon. And why does Amazon build its own? That might sound wasteful, and that might not be the right solution for you. Well, two reasons. A, this model goes way back to, I said, the 90s, and in that case, there maybe wasn't a lot of third-party stuff available. But to today, Amazon's scale is such, scale and complexity is such that sometimes the external tools either don't do the trick, or there's a model I'm going to share, we'll take some third-party tool or external tool and build around it to make it work for Amazon. And the whole point is to reduce that undifferentiated heavy lifting so we can increase the amount of time teams spend on value-added activities, really, which is what DevOps is all about. All right, and that's the Amazon architecture. You might have seen this slide. If you've seen this slide in other people's talks, it's my slide. I'm the one who went to the internal tool and took that picture, and everybody copies me. If you see a different pattern, then they did their own. And every dot there is a service. It's insane, and there are lines between the services showing lines of dependency. And I look at that and I think, this is impossible. No company could run like this. But then I think about it. Each of those dots is owned by a two-pizza team. And then each of those two-pizza teams rolls up to an org that owns a bunch of those dots. And each org rolls up to something else, and it's fractal. And that's how it can operate. So let's start with our first example. That's enough of the background. Let's talk about example. This is the Amazon detail page, something I think everyone here has seen at some point in their life if they ever bought anything on Amazon. It's where you go to buy stuff. I just bought one of these Fire HD 8 tablets after losing mine on an airplane recently. And so this is the detail page, and you might think, okay, this detail page is a team in charge of the detail page, but it's not. It's actually dozens of teams, actually hundreds of teams, because the detail page is running on a framework created by a two-pizza team called Buying Experience. They run the framework so that people, different teams can deploy widgets, back-end widgets, that the page calls in parallel, makes hundreds of calls to render the page. It looks like this. You can see on the left, there's a image widget. You can see on the right, there's a title widget. There's an average ratings widget. There's a AC badge widget. And I'm only showing you like a half a dozen out of the hundreds of calls that are made. And each of those widgets is owned by different teams. Now, a team can own multiple widgets, don't get me wrong, but like each of those widgets is owned by different teams, and they can be deployed independently, which is really powerful, right? Being able to deploy independently is really an agile way to do things. But the other thing about it is the resilience factor. The concept of graceful degradation. That says that if it's not the image, and it's not the title, and it's not the price, it's not one of those three things. If you can't see the average ratings, or if you can't see the AC badge, you could still make a purchase. You're getting a degraded experience, but it's a gracefully degraded experience. You might not even notice it. So instead of being hard down when any one of these widgets is down, we have this graceful degradation where customers, it's still available, and customers can still make their purchases. So that's the resilience aspect of it, all enabled through a framework. Our next example is Amazon Search. Now, to get to that detail page, you might have gone through Amazon Search. I'm going to search for chaos engineering, and it will be apparent why in a moment. So I search for chaos engineering, and I get over 1,000 results. Search is big. Search is big scale. There's over 300 million active users, 84,000 requests per second on Prime Day a couple of years ago. So it's taking a lot of requests. There's a lot of data. There's a lot going on there with search. Let's talk about chaos engineering just for a second. Why did I mention chaos engineering? You can read the definition of chaos engineering. It's from this book, which was then put into something called the Principles of Chaos, which I linked there. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. Who here has heard of chaos engineering? Who here has not heard of chaos engineering? Who here will not raise their hand no matter what I say? Okay. So in summary, chaos engineering is that, but basically it's a resilience strategy. It's a way of simulating the kind of faults that you might encounter in production with your system by actually injecting those faults in a scientific controlled manner to assess whether your system can withstand those faults. It's not about creating chaos. It's about being defensive against the chaos, building against the chaos. So in Search, there is a team. It's a two-pizza team called the Search Resilience Team. Now, they don't have a neat logo like Buying Experience does, so I created a logo for them. There it is up in the corner. I'll share it with them later. They'll be thrilled. They're a great team. They're actually based out of Tokyo, strangely enough. I don't know why, but great team. And they consider themselves to be what they call an operational excellence team, but really their goal is to drive the resilience of Amazon search services. And that means 40 plus services on the back end of search with a whole variety of two-pizza teams. Some two-pizza teams might own more than one service, so I don't know if it's 40, but there's many two-pizza teams there. And one of the things that they worked on, and they shared with me, was how can they actually help teams in search do chaos engineering? Now, when you're going to think about chaos engineering, the first thing, if you're running on AWS, you might think of is this, fault injection service. Fault injection service is an AWS service. Anybody in the room who's on AWS can use it. You don't need a search resilience team. So fault injection service lets you define targets. You know, they might be like EC2 hosts or Lambdas or your databases or whatever, and define actions you're going to take on those, like kill the EC2 server or inject latency, all with safeguards and controls. Now, without the safeguards and controls, you're not doing chaos engineering, you're just doing chaos. Safeguards and controls means you define metrics that if they go into the red, you roll back the experiment immediately. And so you can run experiments. And fault injection service is a third-party framework, right? When a third party owned by AWS, now AWS happens to be owned by Amazon, but .com users are using AWS like any other customer would. So from an Amazon.com developer's point of view, FIS, or fault injection service, is a third-party framework. So they're going to use that. So that's an example I gave. But they're going to do what I said. They're going to build around it. They're going to build a bit of scaffolding around the existing framework to make it work best for them. And the kind of experiments they do, just to give you an idea, they're running ECS, which is Elastic Container Service. So for instance, you can drain an instance. So one of the nodes running containers, you could make it drop all the containers. You could actually kill the node. You can inject latency. You could mess with the ports, right? These are things that FIS can do that Search is doing. Also, I list down there is other things that FIS doesn't do that Search also wanted to do. They wanted to do load testing, and they wanted to do emergency lever activation. Now, nobody in the room probably knows what that is. I will share with you what that is later, but it's a type of experiment they run. So when I said they took FIS and they built around it, so there's FIS in the middle, this is what they did. They said, okay, we'll start with FIS. We also want to be able to run these other events, these load testing and emergency lever things, right? Then they said we want to have a graphical UI so that technical and non-technical folks can do experiments and see the status of experiments. And also, in creating the UI, they created an API so that the teams themselves had a technical API they can call into. They wanted to be able to run on a schedule. Now, this is interesting. When they created this framework, FIS did allow you to run on a schedule, but you had to do some plumbing yourself with some of the eventing services. Now that's no longer true. FIS actually lets you do native scheduling within FIS, so that's almost not necessary, but at the time they wanted to enable that. Running with deployments, similarly to run with a deployment, right, means that integrated into a pipeline, and FIS will integrate into various pipelines, but internally at Amazon, we use a proprietary pipeline system that's existed since forever and been improved upon. So to make that integration easier, the Search Resilience team integrated it with that pipeline and just gave the APIs to the teams to use. Now this one's important. Remember I talked about guardrails. SLOs are service level objectives. They made every team in search define one or more SLOs that are their critical metrics. If these SLOs go out of whack, it means there's something wrong with that service. And they made them define them, and they actually built a system to store them. And now that they've stored these SLOs, they can integrate FIS with that system and use those SLOs as guardrails. So if you're running an experiment and any of your SLOs go out of whack, the experiment stops and rolls back. And on cord, this comes from the Toyota production system. In a physical factory, any worker was empowered to pull the cord, physical cord, and stop the line if they saw a quality problem. Similarly here, anybody in search can stop all experiments. Like there's something going wrong, we're going to stop all experiments. And metrics and insights. Of course, FIS offers metrics and reporting, but they wanted to create a specialized report all up for search leadership across their 40 different services to show them. So it's taking the existing framework and building another framework around it, and it looks like this. So you can see FIS over there on the right, and to the right of FIS is the actual, we're saying ECS and EKS, those are the actual search services that are being experimented upon. It's the box on the left I want you to look at, the orchestrator service. They built this orchestrator so they could do things like exactly what I was telling you about. You could see the API gateway, provide an API. You could see the andon API, provide an andon cord. You could see the Lambda and the DynamoDB database there for scheduling, provide scheduling. So they built this capability around FIS just to make it easier for all 40 teams to onboard onto chaos engineering and do it all up. So in the resilience, hopefully you could see it already, but the resilience benefit here is you have this continuous experimentation and learning, which again is a very DevOps thing, right? You're constantly experimenting and learning about your system. And I promised to tell you what an emergency lever was. That's what an emergency lever is. It's a rapid process that allows you to fix the system when the system's starting to crash, starting to go awry, right? You're running search and things are starting to brown out. You pull the lever. What does pulling the lever do? Well, this is what it looks like normally. This is a search result on Lego, and you can see all kinds of stuff there. You pull the lever, it shuts down non-critical services. Just like before when I was talking about the detail page, that graceful degradation. So you still get an experience as an end user, but you might not have the reviews. You might not have all the shipping on there, but you do have the image, the price, and the title. So this is better than going hard down. Instead, you offer a gracefully degraded experience to your end users, and they could still make purchases. So the emergency lever is yet another framework. Inside Amazon, inside the .com side of Amazon, there's an emergency lever framework that folks can onboard onto and do things like this. And the way they do their chaos engineering is they'll stress the system, pull the lever, and see the stress go away. All right, our last example is, I hope I'm doing well on time here, our last example is the Amazon Relay app. Now this is an app you could download today from the Android or iOS store. But unless you're a long-haul trucker, it really won't do much for you. Any long-haul truckers in here? Not seeing any. All right, so you probably don't want to download the app. These big rig trucks, okay, so these are not the trucks that are delivering stuff to your house. It would be kind of funny if they did. I could see one of these pulling up in my cul-de-sac, but no. These big rig trucks are not the trucks that deliver stuff to your house. Trucks that deliver stuff to your house we call last mile. This is middle mile. Middle mile is getting stuff from the vendors to the warehouse or from the warehouse to another warehouse. Amazon has a very sophisticated, advanced model for where any item should be at any time in a given, between warehouses. That model is totally academic and meaningless unless that stuff can actually be put where it needs to go. So this app is the manifestation of that model. It's this model made real. It tells the truck drivers where to go, when to go there, what to pick up, where to take it. That little scan code, that's a gate pass that gets them into the yard of the warehouse. There's navigation, all kinds of things. It tells them what to pick up and what time to go there, right? So that's what the Relay app is. And the Relay app architecture looks like this. So starting where that arrow is on the right, it's got multiple backend services they call modules, so I decided to use that name. Multiple backend services, all running serverless. Lambda is our serverless compute, and DynamoDB is our NoSQL serverless database. So all running serverless modules. And in the front is this gateway system. The gateway system is using API gateway to take requests from the mobile device and route them appropriately to the right backend services, depending on which API was called. You can see it also does some authentication and other cool things like that too. The thing to keep in mind here is that there is no shared infrastructure between any of these. They're each module and the gateway are independently deployable, each with their own pipeline, each running in their own AWS account. And this is a framework, right? The gateway folks have designed the gateway such that modules can be added and modified independently and work with the gateway as long as they're adhering to the requirements of the gateway API. And they wanted to make it more resilient, so they decided to go multi-region. AWS has this concept of regions. A region is a set of multiple data centers where we host AWS services. You can see one on the east and one in the west here. There's multiple, but there's east and west. They're the ones I wanted you to look at. They're operating out of east. They also want to operate out of west. Now, do you need to go multi-region? Probably not. Multi-region is for the very highest resilience needs. There's also other ways you could achieve resilience, but they decided that multi-region was the right approach for them. And if you look at each of these backend modules, they're each owned by an individual two-pizza team with their own code and their own autonomy. So the frameworks team, working with the teams, decided which ones are the critical ones and which ones are the less critical ones. And working with the critical ones, they said to them, here, we'd like you to design your system to be multi-region, which means putting the Lambda in 2 regions, which means replicating your database across the regions, which is something that AWS natively supports with a feature called global tables. So that individual two-pizza teams working with the framework team were able to decide, yeah, we're going to make this service multi-region. We're not going to make that service multi-region. And the result is this. So you see if a request comes in from a truck on the East Coast, it's going to go to the top API gateway in the East. Then it's going to go to the top service of module A in the East. Same thing, it's going to go to module B in the East. Now, if a request comes from a truck in the West Coast, it goes to the West Gateway. Now we're doing the dotted lines. It'll go to module A in the West, which is a critical service. That's why it's multi-region. For the other module, it's less critical. What does less critical mean? Maybe it's a GPS module, right? You can get your maps from Google or Bing, right, instead of from the app, right? So GPS is less critical. It doesn't exist in the West, so it'll still send that request to the East region. And in the case of an issue where they determine that something's going on in the East region that is affecting the way the service is running, they could do a failover. Failover means they're going to stop all requests going to East, and requests are only going to go to the West. And when that happens, that's great, because now we're out of the East region, we're going through the West Gateway, we're going from Module A to the West version of its service. How about Module B? We're still going to the East version, which means one of two things. Either it's going to still work, because we failed out of Region East, but it doesn't mean Region East is, hard down. That doesn't happen. It just means we failed out of it for some reason. So either it'll work for Module B, or it won't. If it doesn't, what is that? That's graceful degradation. We've already talked about that, feels like a dozen times, right? Then that's fine. So they won't have, they'll have the system that tells them where to go and what to pick up and gives them the key to get in, the scan code, but they won't have their GPS maybe, or maybe they won't have their little chat feature. And a reminder, these are all independent two-pizza teams, independent services in independent AWS accounts, all running separately, but together. So together, through well-defined interfaces, what we sometimes call hardened APIs, but independently in that they're using their own AWS account, their own deployment pipeline, and their own deployment system, all supplied by, this is going to be our third one, we're talking about Builder Tools. Builder Tools is a team within Amazon that provides tools across all of Amazon, across .com and AWS, that everybody can use, to get AWS accounts, to build pipelines, to do deployments. Now, I told you two-pizza teams have autonomy, right? Is it possible a two-pizza team might choose not to use these tools? Yeah, absolutely. Is it rare? Yes. I mean, I was working in the early days of moving to AWS. I was working with a team that was one on the forefront of using AWS services, and they found that the internal pipelines didn't work well for them at that time. They do now, so they decided to use instead Code Pipeline, which is the AWS service. So they're free to do that. It takes it incurs some cost on them though, right? Because if you're not using the standard tools, then you're responsible for making sure it works. More undifferentiated heavy lifting. So we got the independent development and deployment. Each of these modules can deploy independently, and the graceful degradation, which we talked about. And now we add to that resilient failover, the ability to fail over to achieve high resilience. All right, and the last thing I wanted to talk about was specifically, and this is a very DevOps concept, is all infrastructure is code. So to deploy those Lambdas, deploy those DynamoDBs, deploy anything you saw here is all done using infrastructure as code, maintained in a source repository and deployed through a pipeline. No infrastructure is ever just manually go in the console and mess with it. And to do that, there's an internal team that maintains a set of template libraries or blueprints. And you can see them here. And the nice thing about the blueprints is that you as a development team know that these blueprints have been reviewed for their security by InfoSec, reviewed for best practices as part of well-architected, and so you can use this infrastructure as code, either CloudFormation or CDK, to deploy your infrastructure. And if you don't want to use one of these templates, there's a blank template. There's a template that just basically gives you an AWS account with a VPC in it, and you could take it from there. All right, to summarize, Amazon Two Pizza teams operate on a they build it, they run it model. But the only way to achieve this, the only way to make this work is with centrally owned tools and frameworks. I don't know if they made that centrally owned part clear. Like you could have tools and frameworks that nobody owns, that are owned by the community, and we actually have a lot of those at Amazon, and those sort of work, but over time, people leave and they end up being abandoned. Eventually, somebody has to take real responsibility for it as if it were a customer-facing service, even though it's only internal-facing. And we talked about these various, the buying experience and search resilience folks, teams and organizations that build and maintain these tools so that developers can do everything from design to operate their workloads. Okay, some resources for you. I don't know if you want to take a picture of that, or I don't know if these slides are going to be made available later, but basically, if you're interested in any of the stories I shared, I go into deeper detail on them, and the first two are blog posts, the third one's a video, the fourth one's also a video. And with that, I believe I have time for questions.